Welcome back. Episode 5 built a shield that judges one action at a time, one step ahead. Today the shield learns to read further, whole plans, whole simulated futures, whole days of a patient's glucose. This is the episode where every station of our spine fires at once. We model dynamics, solve over time, explain failures with cores, and guard not actions but trajectories. And it all rests on one trick so simple you may laugh when you see it. Let us go read the future, carefully. Why is a plan harder to judge than an action? Look at this little trajectory. Oxygen starts at 2.6. The plan makes 4 moves, and every single one respects episode 5's rate limit. Each step is gentle, each step would pass a one-step shield in its own moment. And yet by the second step, the tank is at 1.85, under the license floor. For innocent actions, one guilty sequence. This failure mode is called cumulative drift, and it is the signature way plans go wrong, small safe steps compounding into an unsafe state, with no single step to blame. And the mirror image exists too. A step that looks alarming in isolation, a sharp cut in narration, a large dose, can be perfectly fine inside a plan that immediately compensates for it. Judged frame by frame, you would veto it; judged as a story, it is sound. Both directions point at the same conclusion: to judge a plan, the judge cannot read one sentence at a time. It must read the whole story. The question is how you hand a whole story to a solver that, so far, has only ever read a single moment. Here is the trick, and it is the only new idea this episode needs. Watch the film strip unroll. A solver reads photographs, one set of variables, one moment. A plan is a movie. So we lay the frames side by side. Make a copy of the state for every time step, do 0, do 1, do 2, up to the end of the horizon. Do 0 is pinned to the sensor reading, that is now. Every later frame is an unknown. Then chain the frames together. Between each consecutive pair, file one constraint, the one-step model from episode 5, do next equals do now plus 0.05 times the action minus 60, stamped once per step, with that step's action plugged in. 5 frames, for chain links, and suddenly the entire movie is a single, ordinary constraint problem, exactly the kind we have been solving since episode 3. The philosophical point deserves saying out loud: to the solver, time is not special. The future is just more unknowns. The verification community calls this bounded model checking. We will just call it unrolling, and spend the rest of the episode discovering how much it buys. The trajectory from slide 2, now in code you can read at sight. The plan, 55, 50, 55, 60, each step gentle. 5 do variables. Pin do 0 at 2.6. Then the loop files 2 tracked constraints per step, M for the model link, F for the floor check. Check, unsat. And now read the core, because it tells the story of the failure with real precision: S0, M0, M1, F1. The starting state, the first 2 chain links, and the floor at step 2. That is the anatomy of cumulative drift, written by the solver itself. From this start, following these 2 model steps, the floor at time 2 cannot survive. Notice what the core does not contain: no action is named as the villain, because no single action is the villain. The sequence is. And notice M2, M3, F0, F2, F3, all excluded, all innocent, exactly the surgical precision we have come to expect. The repair is one list: swap in 58, 60, 64, 70, rerun, and the verdict is sat. Same code. The cost of asking about a different future is, once again, nothing. Once time is unrolled, a whole new language of properties opens up, things you can say about a path that you simply cannot say about a point. 4 verbs cover most of practice. Never, the safety verb. The floor holds at every step, yesterday's point check, quantified across the horizon. That is what we just ran. Eventually, the progress verb. By the end of the horizon, the target is reached, oxygen back above 2.5, the tank recovered. Safety says nothing bad happens, eventually says something good does. A plan can be perfectly safe and perfectly useless, so you usually want both. In total, the budget verb. Cumulative energy under the cap, total chemical dosing bounded, sums over the unrolled steps, one sum expression each. And for at most, the duration verb. Time spent in a bad region is bounded. Pause on that one, because it is the verb that real clinical guidelines are actually written in, and it is where we go next. The engineering miracle, all 4 compile to the same episode 3 vocabulary. Comparisons, sum, and if, over unrolled variables. No new machinery. Just new sentences. Now the clinical case, from a domain my group works in, decision support for type 1 diabetes. Dosing policies, whether written by clinicians, learned by reinforcement, or drafted by a language model, are evaluated on simulated patient trajectories long before anyone trusts them near a person. And the guideline that matters most is not about any single dose. It is called time below range, TBR. The fraction of time glucose spends below 3.9 millimoles per liter must stay under 4%. Because the danger that dominates everything else in this domain is hypoglycemia, going low. Highs are harmful over years, lows are dangerous tonight. Here is why this guideline is interesting to us. An aggressive dosing policy can look wonderful on averages, lower mean glucose, tighter control, impressive plots. And hiding inside those averages, a handful of low excursions that the summary statistics politely smooth away. TBR is precisely the property that averages hide, and it is a trajectory property. You cannot see it in any single dose. It only exists over the whole simulated day. Which is exactly the kind of thing unrolling lets a solver read. Make the guideline a constraint, and whether a policy is acceptable stops being a matter of opinion. Time below range, as a constraint, in 14 lines. A 25-step horizon, think of it as a day at course resolution. Glucose variables G0 through G25, chained by deliberately simple dynamics. Next glucose is current glucose, minus the insulin effect, plus the meal effect. Every link tracked, as always. Then the counting idiom, and watch the counter. If of GT below 3.91, else 0, each time step becomes a flag. Sum adds the flags, that is the count of low steps. One comparison caps the count, at most one low step in 25 is our 4%. 3 lines, and a clinical guideline has become a filed constraint. The moderate policy, SAT, 0 low steps. The aggressive policy, bigger meal boluses, more basal, unsat. And its core is instructive, TBR cap, plus essentially the entire dosing chain. At first that looks unhelpfully large, but it is the truth, a trajectory property implicates the trajectory. The whole day, together, violates the guideline, which is exactly what the honest judgment should say. And the idiom generalizes for free, time above range, counting alarms, bounding lows during the night window only. One pattern, many guidelines. Time for the uncomfortable question this episode has been walking past. Every verdict so far, the plan cores, the TBR judgment, leaned on a model of the world. Our little linear physics on the slides, in research practice, often a learned neural simulator, a world model trained on plant data or patient data. Plans are only as trustworthy as the futures they are judged against. So, who verifies the world model? The same solver, pointed one level down. 3 checks carry most of the weight. Physical invariance. Some things are simply true: more insulin never raises glucose, mass is conserved, mixed tanks do not spontaneously unmix. Assert the invariance negation over the model's behavior within operating bounds, and ask for a witness. Unsat means the model respects the invariant everywhere in bounds, a certificate. Sat hands you the exact input where the learned model breaks physics. Version consistency. Learned models get retrained. Encode old and new, bound the inputs to the operating region, and ask for a disagreement above tolerance. SAT returns the precise input where the versions split, review that, not 10,000 random samples. And sanity envelopes, predictions must land in physically possible ranges. A simulator that outputs negative concentrations is disqualified before any plan is judged against it. Notice the shape: neural proposes futures, symbolic checks them against physics. The pattern of this whole series, one level down. One more gift from unrolling, and it is my favorite in the whole series. Real futures are not deterministic: inflow surges, missed meals, sensor noise. What you actually want to claim is robustness. This plan survives every disturbance up to some size. But that is a for-all statement, and solvers, remember, answer exists questions. Is there an assignment? So invert the question. Turn the weather on. Give every time step a disturbance variable, bounded, gusts of at most 0.2, say, and then assert the thing you fear, that some step dips below the floor. Now read the 2 verdicts with fresh eyes. SAT no longer means good news. SAT means Z3 has found the storm, a concrete, step-by-step disturbance sequence that sinks your plan, ready to hand back to the planner as a counterexample. And unsat is the prize: no disturbance within bounds, out of infinitely many possible futures, can cause a breach. A universal claim, proved by failing to find a single exception. Our good plan from slide 4, with gusts up to 0.3, SAT, the storm is 3 worst-case gusts in a row, breach at step 3. With gusts up to 0.2, unsat, provably robust. Same plan, 2 bounds, and the solver has not just graded the plan, it has measured its weather rating. Where does this actually run? 3 places in my group's research pipelines, and I will label them honestly as exactly that: research pipelines, the proving grounds where trust gets earned before anything touches operations. First, offline reinforcement learning for treatment plans. Candidate control policies are exercised inside learned world models, thousands of simulated rollouts, and every rollout is swept for invariant violations before a policy is even shortlisted. The solver is the auditor of the audition. Second, clinical policy evaluation in glucose control. The TBR constraint from today runs as a hard gate in simulation studies. A policy that cannot certify the guideline on simulated patients never reaches the comparison tables, however pretty its averages. The guideline is not a reviewer's preference, it is a filed constraint. Third, multi-step agent plans. Language model agents that draft tool use plans, migrate this data, transform it, deploy the result, have the entire plan unrolled and checked against resource limits and ordering constraints before step 1 executes. The same unrolling, with steps of a workflow instead of steps of time. Different pipelines, one habit: no multi-step commitment without a whole story verdict first. The honesty slide, for entries, and today they matter more than usual because futures are where overclaiming is easiest. 1. Horizons cost. Every step adds variables and constraints, long horizons on fine time grids grow the problem quickly. Bounded model checking means exactly what it says, verified for T steps, silent beyond. Choose T to cover the decisions that matter, and say so. 2. Counterexamples are model relative. The storm Z3 finds is a storm in your model of the world. If the model is wrong, both the reassurance and the alarm inherit the error, which is precisely why slide 8, verifying the model itself, is not optional decoration. 3. Continuous time is discretized. Reality flows between our sampled steps, and a trajectory that is clean at every sample can wiggle briefly between them. Conservative margins and sufficiently fine grids manage this honestly, pretending it away does not. 4. Statistics beyond counting. TBR counts steps, and counting is solver-friendly. Full distributional guarantees, tail risk, conditional value at risk, the machinery serious clinical evaluation eventually needs, belong to other tools. Knowing where Z3's comfort zone ends is part of using it well. Verified futures are bounded futures. Say the bounds out loud, every time. 3 ideas to carry forward. 1. Time is just more variables. Unroll the horizon, chain the frames with your one-step model, and a whole plan becomes one ordinary constraint problem. The solver reads the movie, not the frames. 2. Guidelines are trajectory constraints. Never, eventually, in total, for at most, the language that regulations and clinical guidelines are actually written in compiles directly to some if and comparisons. 3. Robustness by inversion. Ask the solver to find the storm, SAT hands you a concrete counterexample, and unsat is a proof over every disturbance in bounds. Next time, everything converges. Episode 7 takes the lint from Episode 4, the shield from Episode 5, the trajectory checks from today, and installs them where this research program actually lives, inside the LLM wiki, as the 4C verification layer, correct, consistent, current, complete. The Series 4 stations become one living knowledge system. See you then.